This is 2016 BC free response question number 6. You are given a function f which has a Taylor series about x equal to 1 that converges to f of x for all x in the interval of convergence. It is also known that f of 1 equal to 1, f prime of 1 equal to -1/2, and the nth derivative of f at x equal to 1 is given by a formula over here. The first question is, write the first 4 non-zero terms and the general term of the Taylor series for f about x equal to 1. Okay, this is the general form of the Taylor series. So first term, second term, third, and fourth, since we want to know 4 terms. And this is the general term. So what we need at this point is just f of 1, f prime of 1, f double prime at a 1, and the third derivative of f at a 1. And from the givens, you know f of 1 equal to 1, the derivative of f at a 1 equal to -1/2, and this is the general formula for the higher derivatives. So I'm gonna set n equal to 2. So the second derivative of the function f equal to 1 over 2 squared, which is 1/4 if you just plug in the 2 over here. And for the third derivative, and you put a 3 over here, and you get the -1/4. Since we know the f of 1, f prime of 1, and those two, I can substitute those derivatives with the numbers I just got. So I have 1 minus 1/2 x minus 1 plus 1 over 8 times x minus 1 squared, and so on. So this is the fourth term. And for the general term, I literally just substitute the derivative with this expression over here divided by the n factorial. So this is n minus 1 factorial. So literally the something are canceled, so only n on the bottom will be there. So part B, the Taylor series for f about x equal to 1 has a radius convergence of 2. Find the interval of convergence. Show that the work that leads to your answer. I'm not really sure why they gave you the radius convergence. Theoretically, you're supposed to find it yourself. So you know an, the general term is this. You do the ratio test, n plus 1 over an. And when you substitute those two in, you will get something like that. And you let n goes to infinity, and the ratio will be approaching to x minus 1 over 2. And you know this one has to be less than 1 for the series to be convergent. And you multiply by 2, you will get x minus 1, absolute value of x minus 1 less than 2. So this is actually what they give to you to say the radius is 2. I just did everything from scratch from the very beginning to get this instead of using the givens. Now at this point, you know the series is convergent for x between -1 and 3. At this point, you need to check the boundaries. So if you let x equal to 3, the series is becoming this one. And you cancel the 2 to the nth power, top and the bottom, you will get something like this, and which is the harmonic, it's alternating series, decreasing, and the nth term goes to 0. So you know this series converges. And for x equal to -1, you plug in -1 into the original series, and you will get 1 over n. This is a harmonic series which diverges. So the interval of convergence is just -1 open bracket to 3. So 3 is included. For part C, the Taylor series for f about x equal to 1 can be used to represent f of 1.2 as an alternating series. Use the first 3 non-zero terms of the alternating series to approximate f of 1.2. Okay, the first thing I did was I just copied the first 3 terms from part A. At this point, all I need is substitute x with the 1.2. So I'll let this thing equal to 1 minus 1/2 times 1.2 minus 1 plus 1/8 times 1.2 minus 1 squared. And when you simplify this expression, you get the answer as 0.905. Make sure you keep 3 digits after the decimal number. Okay, the last question is to show that the approximation found in part C is within 0.001 of the exact value of f of 1.2. So I'm gonna use the alternating series error bound. So f of 1.2 minus the polynomial P2 1.2, which basically is this, okay, and should be less than, so we know this number, and should be less than the next term, the next unused term, which is the 4th term. Okay, we used those 3, and the next term will be this one. Okay, I substitute x with a 1.2. I simplified this expression is 1 over 3,000, and this is definitely less than 1 over 1,000, and which is the 0.001. So that's the answer for D.